All right, let's go ahead and look at this. Define a parallelogram. Can someone define a parallelogram to me? Yeah.
Like an equilateral or like a four-sided figure.
Quadrilateral.
Or there we go, yeah. Where the opposite angles and sides are congruent and parallel.
Per the definition of parallelogram, it's a quadrilateral where opposite sides are parallel. The definition is just that they're parallel.
Oh.
The theorems then say that stuff's congruent. All right, so your definition of parallelogram should have something about a quadrilateral and opposite sides being parallel. That's all that should be in the definition. It's a quadrilateral where opposite sides are parallel. So a quadrilateral where opposite sides are parallel. Then in those theorems, this is where we can say that extra stuff, that opposite sides and angles are congruent. And diagonals bisect each other. Has to be bisect, not intersect. Intersect, I was talking about that in the other class. Intersect just means that they hit each other. Bisect means they cut each other in half. So that's a lot more information. Bisect versus intersect. All right, that's a parallelogram. That's what we learned yesterday. Before we start today's lesson, what questions do we have from the homework? Make sure I have my homework somewhere. Isabella. 26. All right, 26. So we were given basically DE equals x plus y, EC equals 12, CK equals 2x minus y, and KD equals 3x minus 2y. So we were given a whole bunch of information, and we had x's and y's, so I need to come up with two equations, right? If I put that information onto a parallelogram, so it did say it's a parallelogram. So they gave us kind of a drawing that looks like this, but better than that, I guess. Good enough. All right, where this is D, this is E, this is C, this is K. Well, they said that DE is x plus y. So I'll put x plus y down here. Then it says EC is 12. CK is 2x minus y. And then finally they say that KD equals 3x minus 2y. What do we know about parallelograms and their sides?
When the opposite sides are equal.
Are congruent, right? So we have this 2x minus y has to equal the x plus y, right? And then the other pair must also be congruent, so that's 3x minus 2y equals 12. I'm going to rewrite these so that the x's and y's are all on the same side. So we're going to subtract an x on the top one from both sides. That'll give me x minus 2y equals 0. And our bottom one is 3x minus 2y equals 12. And now we just have to use elimination, which means I need to create a zero pair. Well, the closest one I have to a zero pair is this negative 2y and negative 2y. Did I? Yeah.
I just have a question on, like, do the, when you set them kind of equal to a number, can they also be equal to, like, another variable, like 2x minus y equals x plus y, or do they both have to be equal to a number?
I like them equal to a number because then everything lines up. Because our goal with elimination is that all the x's or all the y's eliminate. So they need to be on the same side so you can see what you need to do to eliminate it. Because right now I'm looking at that negative 2y and negative 2y, and I'm like, well, if it was negative 2y and a positive 2y, they'd cancel out if I added it. So I just either need to multiply the top one by negative 1 or the bottom one by negative 1. I'm going to multiply the top one by negative 1. Which is going to give me negative x plus 2y equals 0. Our bottom one is still 3x minus 2y equals 12. Now I can add these two things together to give me 3x minus x, which would be 2x. This would turn to 0, and that would just equal 12, so x would equal 6. Is that far enough? You think you could plug that into the other one and get your y value?
Yeah.
Okay. Do you mind if I ask what'd you get stuck on, I guess?
I just didn't know how to put it into the equation.
Oh, okay. Does that make sense now?
Yeah.
Okay, good. Other questions? Hamza.
There's something like 18.
Yeah. Okay. I'm tracking. Yeah.
Alright. Like, so you know that how you like start from A and then you do like up 3 over 3 to
Mhm.
find D.
Mhm.
Like, how do you know where to start from? Like, how do you know where to start from A and go up 3 over 3?
Because it's a parallelogram. It's a parallelogram. So currently, if you would, real quick, I don't know if this picture is going to help at all. So they started off with, let me erase some stuff real quick, see if I can. So they're basically saying you don't know C, right? You know A, B, and I guess this would be my D. That's all we know. Well, a parallelogram has to have same length sides. So the stuff up here has to be the same length, and this side has to be the same length as over there. Is there another parallelogram we could create with those 3 points?
No.
So that's how I know A has to go to B. I'm just trying to get the length of this line. I want this same length right here, so that these are the same side, and they need to be parallel. So look at here. The only way we can have a parallel line is if it cut through here. So I'm looking at a line up here. All right, that's the only way I can have a parallel line is if I have something right there. All right, so that's my top. This line has to be parallel with whatever line's here. So you could just kind of eyeball it and say it's got to be about here. What you did with the 3 up, 3 over is to make sure you know the exact point of it. You're not just eyeballing it. All right, so you can kind of eyeball it about where it's going to be, and then use that up 3 over 3 to get that exact value. Does that make more sense?
You just have to see where you're going to, like, see about where it is.
Yep.
And then that'll give you a clue where to start from.
Yep, absolutely. Yep. Because if you went the wrong way, right, that's not a parallelogram. If I went up 3 over 3 that direction or something, I'd be like, okay, that's not a parallelogram.
Yeah.
That's a rhombus or something. All right, yeah. So eyeball about where you should go, and then get that exact measurement afterwards. Okay? Other questions? Okay, if there's no other questions, I just want to tell you something real quick. I had a conversation with a parent, and I think it happens to all of us. I don't think there's anyone in here anyway. But he was talking about, he remember being in math class, and he'd have so many questions, and he would just hope someone asked all those questions. All right, don't be that person that just waits for someone else to ask a question, and if it doesn't get asked, then you don't ask it. Just ask questions. Ask questions, ask questions, ask questions, and you'll get stronger and stronger at it. All right? Today's lesson. Yesterday we talked about theorem 5.1, 5.2, and 5.3. 5.1 said opposite sides of a parallelogram are congruent. 5.2 said opposite angles of a parallelogram are congruent. 5.3 says diagonals of a parallelogram bisect each other. You only can use these 3 if you already know it's a parallelogram. So think proof-wise. If you are given a parallelogram, then you can use all 3 of these. If you're given a quadrilateral and you need to prove it's a parallelogram, you're going to use the stuff that we're doing today. So yesterday was if I'm given a parallelogram. Today is if I need to prove it's a parallelogram. So let's go through all 4 of these. So we're going to go through theorem 4, 5, 6, and 7. Theorem 5.4. It says that if both pairs of opposite sides of quadrilateral are congruent, then the quadrilateral is a parallelogram. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So in this case, you don't know it's a parallelogram. You're given a quadrilateral. So let's say we're given a quadrilateral. So we have a quadrilateral, we'll call it A, B, C, D. Now this says if both pairs of opposite sides of a quadrilateral are congruent. So if BC equals AD and AB is congruent to DC, then ABCD is a parallelogram. So if you can show this, or this is given to you, then you know for a fact it is a parallelogram and everything that goes along with it. Once again, this is if you're given a quadrilateral and you need to show that it is in fact a parallelogram. All right, 5.5 says if one pair, so this time we like to focus on one pair of opposite sides, but it has to be both congruent and parallel. Then the quadrilateral is a parallelogram. So once again, that's if. If you're given a quadrilateral, so if I'm given a quadrilateral, let's call it A, B, C, D, and I can find one pair. I can find one pair. Let's call it BC and AD. And I can show that BC is congruent to AD. And I can also show that they are parallel to each other. That is parallel and congruent. Then once again, A, B, C, D is a parallelogram. Yeah.
Sorry, was the last one we just did, was that
Yeah,
5.4?
I'll go back to it. Yeah,
Oh.
that was theorem 5.4. Guys, you might want to write it on your theorem sheet.
Oh.
You can write it there. I just didn't give much room there because I just wanted to draw it on there. Yeah.
Could we write down like if you are like the hints that you give, like if you already know?
Sure.
It's a parallel.
So you could put on the first three like I already know it's a parallelogram, and the rest of them are if I don't. It's nice how it's set up that way. The first three are if you know, and then the rest are if you don't know. So yeah, absolutely you can put that on there. So the question was, can you just actually write and circle something saying that this is if you know? You can absolutely do that on there. The only thing you can't do is do an exact example, like if you're given this proof, do these steps. You can put little notes to yourself on there. All right, so theorem 5.4. Theorem 5.5 is you just need two sides that are congruent and parallel. Theorem 5.6 says that if both pairs of opposite angles, so you need both pairs of opposite angles on this one, of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So this is if you have a quadrilateral, there we go. If you have a quadrilateral, we'll call it ABCD again. So I give you a quadrilateral. If you can show me that angle A and C are congruent, and you can show me that B is congruent to D, then you have a parallelogram. All right, then we'll go to our last one. 5.7. If the diagonals, so this one's focusing on the diagonals of a quadrilateral bisect each other, then the quadrilateral is in fact a parallelogram. So if you have a parallelogram, not a parallelogram, we just know it's a quadrilateral right now. If you have a quadrilateral A, B, C, D, and you can slap some diagonals on that guy. And now if you could show that it's bisecting. Remember, bisect means it cuts in half. So that would mean, let's just call this point E in the middle. That means if BE is congruent to ED, and AE is congruent to EC, that means it's bisecting. So if you can show that, then ABCD is a parallelogram. Once again, your first three theorems, 5.1, 5.2, and 5.3, are based upon the fact that you already know it's a parallelogram. The next ones, 5.4, 5.5, 5.6, and 5.7, all are based upon the fact that you're given a quadrilateral and you need to show it's a parallelogram. All right, that's really good for proofs. Because your question is, when you're doing a proof, is ask what I'm given and what I need to prove. If I'm given a parallelogram, use 5.1, 5.2, and 5.3. If you need to prove something's a parallelogram, use 5.4, 5.5, 5.6, and 5.7. Yeah?
Do you need our other theorems sheet for chapter 5?
You should have it, yeah. Because we can use like side angle side. We can prove that two triangles are congruent to come up with segments being congruent, kind of thing. We'll talk about one of the proofs today that you could actually use triangles on it to solve it as well. Questions on any of these? Okay, then let's jump into a proof. So how I'm going to let this guide me. Notice my given is I'm given parallelograms. And I need to prove two angles are congruent. So I'm not proving anything's a parallelogram. I'm given parallelograms. So that means I should be looking at theorem 1, theorem 2, and theorem 3. Those will guide us on what we need to do. Let's first write down our statements. See how it says ABCX is a parallelogram? A way to shortcut that is just write parallelogram ABCX. You can absolutely write ABCX is a parallelogram, but this means the same thing. Just a couple less words. And they're also given that we have a parallelogram, DX, F, E, and that was all given. Cool. I need to show that angle B is congruent to angle E. So now look at your theorem sheet. There's only three we can use. 5.1, 5.2, and 5.3. Which one of those deals with angles? Yeah, Sam. 5.2. 5.2 says that opposite angles are congruent. We need to get from B all the way to E. I need to get from B to E. What's the key to get from B to E? Cece?
Angle B equals
Be careful with naming an angle x. There's actually 4 angle x's.
Angle CXA equals angle B. Wait, yeah, and angle FSC equals CXA, and FXD equals FED.
Yeah. The B and E are okay naming them because there's only one angle there. The x is the only one that you have to really, really focus on. So what you said is that angle B is congruent to CXA, right? Let's start with that. Let's start with angle B is congruent to angle CXA. What lets me say that?
3 and 5, 2. Wait, yes. Wait, hold on. Yes, yeah.
You sure?
Yes.
Okay, yeah, it's theorem 5.2. What can we piggyback on theorem 5.2? Well, we could also say that angle E is congruent to angle FXD, which in the picture might look like, I don't know that everything's equal yet, so I'll just put a double dash. That's theorem 2. Theorem 2 strictly says that this angle is congruent to that angle, and E is congruent to that angle. How do I connect these two angles? If I could just show that these two angles are congruent, we're done. Can I show that these two angles are congruent somehow? Yeah.
Vertical angles?
Vertical angles. So maybe we'll use that in step 3. Step 3 would be something like angle CXA is congruent to angle FXD. And that would be vertical angles. Then I could say angle B is congruent to angle E. Why can I say that angle E is congruent to angle B? Why can I say that? Sean? Transitive property. Transitive is the best. I bet you several of you are like, would substitution work? Substitution will work, but transitive is the best because I'm going from B to there, and then from there to there, and then there to there. So it's a bunch of elements. It's kind of that train. So that would be my transitive. Look at that proof right now. Ask yourself, do all those steps make sense? Because at this stage in the game, when we're doing something in class, you have to make sure it makes sense. And if you're not sure of a step, ask. Are we all okay with this proof? It makes sense. Okay, our next proof is a little tougher. I didn't quite give you enough space. Well, there is enough space, just don't write super big. Try to write small. We have to do something like, I think it's 7 steps, 8 steps. So it's kind of 8 steps. So kind of pace yourself so you can go 1, 2, 3, 4, 5, 6, 7, all the way down to 8. All right, step 1. Step 1 we can kind of do in 2 little tiny things. So step 1 is our given. So step 1 is going to be that we have a parallelogram A, B, C, D. And we also have M and N are midpoints. And that's our given. All right, ABCD is a parallelogram. That's everything that goes with it. So that means that this segment is parallel to that. It tells me that DA is parallel to CB. It also tells me that DC is congruent to AB. It tells me that DA is congruent to CB. It tells me angle D is congruent to angle B. It tells me angle DAB, DAB, is congruent to DCB, DCB. Can we all picture that? All right, before I focus on the parallelogram, like I always say, if they give you a sentence, see that midpoint thing? They tell me M and M are midpoints. Always unpack the given in your next step. So my step 2 is to unpack what it means to be midpoints M and N. And more specifically, what segments are congruent based upon the fact that M and N are congruent. Tori?
Segment DN is congruent to segment MC, and then segment AM is congruent to segment ME.
Perfect. And anytime I'm explaining a sentence, you're just going to put definition of midpoint. All right, we have definition of midpoint. So we have basically DN, I'm going to draw it on there, is congruent to that. That's congruent to that. Hold on now. We're trying to prove that AMCN is a parallelogram, right? And they're talking about sides. Well, if you go back to all the 3 ones that prove something is a parallelogram, this one deals with sides, 5, 5, and 5, 4 deals with sides. 5, 4, you need all 4 of your sides. This one we just need parallel and congruent. So it's going to be one of those 2. It's going to be one of those 2. So before I do either one of them, I need to prove that NC is congruent to AM. Does it make sense that it is? They are congruent? Because what do we know about DC and AB? What do we know about those 2 lengths? Isabel? They're the same length because it's a parallelogram. All right, so that distance here we'll do 3 tick marks, must be the same as that distance here because it is a parallelogram. Opposite sides are congruent. Let me shortcut this real quick. I'm not going to say the full lengths are. What I'm going to do instead is I'm going to say, well, dn plus nc. I probably shouldn't put the line over it because we're talking about lengths here. dn plus nc is going to equal am plus mb. And that would be, correct me if I'm wrong, wouldn't that be theorem 5.1? Does theorem 5.1 say opposite sides of a... Oh, yeah.
Could you just say BC is going to be AB?
You absolutely could, but we have to break it down into this fashion anyway. So you would just have an extra step than I do. All right? All right. So now we have those two things. What I want this to say, I want it to say that NC equals AM. It looks like it should be super easy, right? Because intuition tells you if you cut something in half and they're both the same length, you have the same thing. But it's a little trickier than that. Because I want DN and I want AM to cancel out. The only way I can do that is if I specifically said above that DN is equal to AM. Did I ever say that yet? No. So you can't skip right to that. But what we can do is we can use substitution to say, well, instead of writing DN, I can write NC there. Then I want to get AM by itself. So instead of writing MB, I can just write AM there using substitution. You'll see why I'm doing that in just a second. So my step 4, we can now say that NC plus NC equals AM plus AM, and this is substitution. Now I just have NCs on one side and AMs on the other side. So I have NCs on one side and I have AMs on the other side. Our next step is to write, I have 2 NCs on this side and I have 2 AMs on this side. The reason's kind of weird on this one. It makes sense though, right? If I have x plus x, it equals 2x. Does anyone want to give me a reason for this? And it's probably okay, whatever you're going to put. Does anyone want to just come up with a reason? Make one up if you have to. Because I'll accept a lot here. No one wants to take a shot? Yeah. Algebra. I'd be okay with that. I'd be okay with algebra. Or addition. It's just addition. It's just what we did. Algebra would be fine. The correct 100%, I'm not going to take points off for math. I'd be okay with math too here. Would be the distributive property. But it's such an obscure way to use a distributive property, I'd be okay with just adding, with just algebra, with just, Mr. Pabian, come on. I have 2 of something, there's 2 of it. All right, but step 6 has a very specific thing. Step 6, I can now say that NC is equal to AM. Why? How do I get rid of those 2's? Grant. Division property of equality. All right, we now have this is congruent to that. Look at the only 2 proofs that have sides in them. One says you need both pairs, opposite pairs being congruent. The other one says, hey, if you have one pair that are congruent, just prove that they're parallel. Is there any way to prove that this line is parallel to that line? And my hint to you is given to you. Yeah. Yep, absolutely. I'm going to instead of putting AB and DC, I'm actually going to put the segments of it. I'm going to put NC is parallel to AM. If you put DC and AB, it doesn't change this at all. It'll be the same steps. And that is just definition of a parallelogram. Because we said starting off that these two lines had to be parallel to each other. DC has to be parallel to AB because ABCD is a parallelogram. That's the definition of parallelogram, that has parallel lines. Definition of a parallelogram is a quadrilateral with parallel lines. All right, so now I know NC is congruent to AM. I know that NC is parallel to AM. So the last step is to say that you actually have AMCN is a parallelogram. And what theorem did I use? Hamza? 5-5. You can either say 5-5, you can put theorem 5-5, you can put 5-5 and then theorem after. I just need to see 5-5. Once again, take a second. Read through that proof and make sure it makes sense to you. That doesn't just seem like Mr. Pavian just made up stuff along the way. All right, any questions for me? What I want you to recognize, yeah, sorry.
On number 3, how do you know, like, why do you do DN plus NC equals AM plus MB? Like, how do you know to do that? To, like, kind of...
So what you could have done is, so we want to get these lengths. I want to get this is equal to that length. I know that because they gave me lengths for a reason. So I need to somehow prove that NC is congruent to that length. So I know that DC is congruent to AB. So you could have written that first. You could have wrote DC is congruent to AB right here, and then broke it down to the individual segments. And I wanted the individual segments because they gave me these midpoints for a reason, right? And these midpoints broke it apart into two segments, DN, NC, AM, MD. So your first step is to write it in those terms. Write those two lengths in those terms. That's how I kind of knew to write it that way. Kind of with practice. Knowing what I want out of it is knowing what I'm going to put into it. I know I want NC being congruent to that because it's definitely one of my proofs. In order to do that, I need to break it apart into segments, so I wrote it in terms of segments. Yeah, all right.
Step 7?
Yep.
Basically just instinct?
On instinct?
Yeah, or do it
It is. It comes from, when I read that ABCD is a parallelogram, I should always in the back of my mind know key facts about it. That this is parallel to that. This is parallel to that. This is congruent to that. So you should keep all those facts in the back of your mind. If you want to, you could write it all on here and then just explain it. And so it was kind of instinct that I knew that, well, I had two sides congruent. Now, either I can prove NA is congruent to CM. That seems like a long way away. Or I can prove it's parallel. I'm going to check to see if it's parallel. Oh, yeah, I remember from the definition that it has to be parallel. So it is kind of instinctual, but it also has a skill to it. Realizing what proofs can actually prove its parallelogram and using that to guide what I'm doing with it.
So on number 7, you put the definition of a parallelogram, but how can you put that if you don't like actually know it's a parallelogram?
ABCD is a parallelogram.
Oh, so those lines must also be congruent?
Those lines must also be congruent. By definition of parallel lines, every segment is also parallel.
Oh, so that's saying that DC is parallel to AB.
I am strictly saying that DC is parallel to AB, but I can also say the small segments are as well.
All right, yeah.
Isabel? Yeah. Other questions? All right, we just have one more to do. It says draw and label. This one's going to go really quick. You just have to know what I'm asking for, honestly. So it says draw and label a diagram. List what is given and what is to be proved. Do not actually prove it. Now, here's the easy way to break these down. See this if statement? It says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Your if statement is going to be the given. The then statement is going to be your prove statement. This is what we need to prove. You are going to take that if statement and you're going to use that to make a drawing. So it says if both pairs of opposite sides of a quadrilateral are congruent. So you are going to draw a quadrilateral, probably one that looks like it's parallel because we're proving it's parallel. But for right now, it's just a quadrilateral. Let's call it A, B, C, D. Well, it says if both pairs of opposite sides of a quadrilateral are congruent. So on your drawing, you're going to draw opposite pairs being congruent. So you'll draw AB being congruent to CD, and you'll draw BC is congruent to AD. So I take that if statement, and I make a drawing out of it. Then what I'm going to do is with that drawing, since that if part is my given, we're going to say what that means in the drawing. So what was given to me is basically that AB is congruent to CD and AD is congruent to BC. That's what's given to me per my drawing. Our prove is just the then statements. So then we're going to write prove. And it says the quadrilateral is a parallelogram. So we just have to say A, B, C, D is a parallelogram. They're not hard problems, but you have to know what I'm asking for. I'm asking you to turn that if statement into a given, draw it, explain what's given, and your prove is the then. All right, any questions on stuff we covered today? Okay, then the rest of the time is yours to work. I'm also going, Hamza.
On exercise 2, what was the statement for number 7 to refer?
So we're looking at number 22. And it's just to explain those values. So 22 has a picture that looks something like... just to explain those values, this right here is 4x plus 1. This one is 7y minus 2. This one is 3x. And this one is 9y. Just because they're kind of hard to read. It did not photocopy well. Bless you. You're welcome. All right, then the rest of the time is yours. I'm going to walk around and I'm going to check your homework. Yeah. Yeah.